Hopefully you were at least mildly successful with that first assignment. I know it is really tough. And to give your brain a little bit of a break, this assignment is not as tough. So hopefully you will be able to fly through this assignment and we can spend a lot of time in class on that 1.2 assignment. When we evaluate a limit algebraically, the first thing that we can try and do is directly substitute the value in for x. If the function is continuous at that point, then we'll be able to find the limit by just evaluating the function. So that's the first thing that I'm going to try with this one. Replacing x with 2 in the numerator and replacing x with 2 in the denominator. Notice I dropped the limit notation because I substituted x in. You keep the limit notation as you're working until you do the direct substitution. In the numerator, we have 2 plus 2 is 4, the square root of which is 2. In the denominator, we have 2 minus 4, which is negative 2, and 2 divided by negative 2 gives us negative 1. So that is not only the value of the function at 2, it is also the limit because the function's continuous at that point. And we couldn't get away without a trig example, so let's see what happens when we substitute 5 pi over 3 in for our x value. Notice again I dropped the limit notation because I substituted. And of course, I want you to think about the cosine of 5 pi over 3 before we go over it together. When I evaluate trig functions, I like to use reference angles. So the reference angle is pi over 3. The cosine is the x value, which goes 3, 2, 1. So we have cosine of pi over 3 is 1/2. 5 pi over 3 is in the 4th quadrant. Cosine as the x value is also positive in the 4th quadrant. So we get a limit of 1/2. All right, because direct substitution is so nice and easy, we're going to move on to composition of functions. So hopefully you remember how to actually find a composition. We're going to take the entire f function and put it into the g function. Now, because I have some work to do with variables on this one, I will be keeping my limit notation until I can substitute that x value of negative 3 in. I'm going to show this in a couple of steps. I know some students still like a little bit of extra practice with compositions or just need that step by step. If you are able to do the composition all in one step, great, feel free to do so. So what I did here was I took that f function, which was x plus 7, and I simply replaced the f of x part of that composition with x plus 7. Now I am going to take all of that x plus 7 and I'm going to replace x in the g function with x plus 7. So just that x will turn into an x plus 7, and then we'll finish off that g function with the minus 3. At this point, I could simplify, I could sub in, or I could simplify and sub in at the same time. Now that I'm going to sub in, I drop the limit notation, replace x with negative 3, and this 7 minus 3 gave us 4. The square root of 1 is 1. Look at that, we are already on our last problem. I bet you are all super excited. Let's start by trying that direct substitution, replacing x with 3. And what we end up with is 0 over 0. Well, that's undefined. That does not mean that this limit doesn't exist. This is actually called indeterminate form. Indeterminate is basically a fancy way of saying we don't know. We don't know what's going on with this function, so we need to do a little bit more work to figure out what is going on with this function. What I notice is my denominator is factorable. So I'm going to start by factoring that denominator. Notice now I have my limit notation back because I haven't substituted in for x yet. And I lost my parenthesis. What I notice now is the numerator and this part of the denominator look pretty similar, but they're opposites. So what I'm going to do now is factor out a -1 from that numerator. I'm still not subbing in for x, so I am still keeping my limit notation. I'm going to rearrange this so that it matches my denominator exactly. So factoring a -1 out of -x gives me a positive x, and factoring -1 out of a positive 3 gives me a -3, leaving my denominator alone. And now we can cancel those x minus 3's. I'm keeping my limit notation because I am not subbing in yet. I'm simply canceling those common factors. I still have an x value over here with my function. Now I can try my direct substitution again. -1 over 3 plus 3 gives me 6. So the limit as this function approaches 3 is -1/6. We already determined the function value does not exist at 3, but the function is approaching this value of -1/6 from both sides of 3. So the limit exists even though the function is not defined.